Hello and welcome to the next video in our series on DevOps and testing. Hi, it's me, Reese, from Reese Teaches Programming, and we are talking about integration testing. Now, as you previously learned in our section about integration testing, this is all about how our components or services interact. So integration testing helps us catch issues in the glue between our services, our databases, our units. Now, right now we've just been messing around with this console application that has a couple of classes in it, and we're going to need to make this a little bigger in order to make this a little more realistic for an integration test. So what we're going to do is set up an ASP.NET Core API project under our solution, and that way we can do some integration testing. So again, if you are working along with me and you are using the .NET Demo Pipeline application that we've been working with in this section, you're welcome to continue doing that. If you want to start from scratch and just build in Visual Studio along with me with a new project, you can do that too. You'll need to create your repo and walk through those steps and make sure it's connected to GitHub so that you have that GitHub Actions .NET YAML file so that we can see our integration tests working in the pipeline. So all of that being said, pause here if you need to figure out how you would like to work on this, and we're going to jump right into it. So in my Solution Explorer, I'm going to right click on Solution and I'm going to add a new project. And I want to get an ASP.NET web application. So I still need C#. We can do, that's good. And we want to look under web, and an ASP.NET Core API project should be sufficient. So we can give it a name. I'm going to call this, like integration API. We do want to configure for HTTPS. We do not need container support. We can leave all of these other items checked by default. And then that will take Visual Studio a second to create. And then we want to find the program.cs file that is under this particular project. If it helps, you can close out of any open other items that you have in here so that you get our web application. So for the sake of simplicity, here in our program.cs, this identifies and sets up a new web application, and we are going to just add an endpoint that this application will respond to. I'm going to call it multiply. And all we want multiply to do is take an int a and an int b and do that multiplication step and return a multiplied by b. And so by setting up this endpoint here, we'll be able to run our web application and go to /multiply and actually see this work without providing a lot more setup that a regular web application would require. Now, it is good practice to separate out your different types of tests that are residing inside of your project. So we have our unit tests in the calculator tests project that we created. And normally we would have like a separate folder for our integration tests. So we could come into our calculator tests project and we would add a new folder and we would call it integration, and then we would put our integration tests into this folder. So let's add a new test class into our integrations folder. So we're going to add a class, and we're going to look for a test class, and we can use the filters over here on the side. We're looking for an MS test class, and if we double click it, it's going to just drop a test1 test class in here. I'm going to rename this to API integration tests. Helps if you spell integration correctly. And I also renamed the file to the same thing. And so before we go any further, remember, as we did in our unit tests, we have to create a reference between these two projects, or otherwise they're not going to be able to see each other. So our calculator tests test project dependencies, adding a project reference, we need to check our integration API and click OK. And then we also need to add the using statement to the top of our API integration tests file so that we'll be able to write test methods that can access our new web application that we have developed. The other thing we'll want to do before we get to work on our test class is making sure that we have the right packages installed. So we'll want to go over to our NuGet package manager and go into our NuGet packages for the solution and see, do we have the ASP.NET Core.mvc.testing package. You might have to put the Microsoft in front of it. So we want Microsoft ASP.NET Core MVC testing package. If it's not installed, go ahead and grab it and get that installed. And don't be a ding dong like I did and accidentally checked the wrong one. We just need this in our test project. It's obviously not going to install in projects that it doesn't belong in. You're just going to get an error. We just need to install the package in our calculator test project. So once you have that all done and you've got your install finished, we can leave the NuGet window and come back over to our integration tests and add our using statement for the package that we just included. Okay, so now we're going to see if we are ready to start setting up our API integration test class. But you can see I've got an error here about my program class, and that is because I have added the wrong using statement. I put the .NET demo pipeline when really we need the integration API. And so that is my mistake, but I wanted you to see what would happen if I didn't fix it. So having the integration API project, which is the project where we're creating our little fake web application, we should now be able to see our program class, which is over here in our program CS where we added in that map-get endpoint. So these two variables, this web application factory and the HTTP client, they come from our ASP.NET Core package, and we're going to use these variables to connect to our little fake web application. Now I'm going to paste some code in here because it's kind of long, but we're going to need this method called setup, which is decorated with the class initialize. So this is kind of like a constructor for our API integration test class, and it's going to set up the factory and client variables that you saw I created here in the class that go ahead and get these objects initialized and this client created that will be able to connect to the web application as it's running. So now we're ready to work with our test method. And so I'm going to call this, we're going to need to change the signature. This is going to be an async task return. We use async task returns usually in our web development projects so that we ping that server connection or that web application connection, and we wait for a response before we proceed. A task object we can see here is at least is part of our API integration test project. and is actually part of the .NET threading class that comes from that wait action, so that we don't get ahead of ourselves as we're waiting for the web server or the application to return a response. We don't proceed, and the action that we get back waits. So we're going to return a task. We're going to call this multiply endpoint returns. Let's correct results. We'll just do all one word. Again, we want to use reasonable names for the, like the class that it's interacting with, the method it's interacting with, what we expect to go on, same way that we did with our unit tests. So this one looks a little different because we're going to have to connect with this multiply endpoint, and we're going to have to pass it the two expected variables, A and B. And since we're working in a web application, this looks a little different because we have to format it like a URL. And I tried to turn my Copilot off so it'll quit trying to spit code at us. So let's see, response. It's like sometimes between Copilot and the IntelliSense, it gets a little chaotic. So we're going to call that client. This is that create client piece that up here, it's an HTTP client using the get async, which we can see sends a GET request to a specified URI as an asynchronous option or operation. And then what do we, where are we going? We're going to that multiply endpoint, and we want to send the A variable, let's send a 4, and B variable, let's send a 5. So /multiply is the endpoint we're going to. We're sending 4 and 5. And then our result that we'll get back, we're going to read that from the content object that comes back of this response that we get back from this HTTP client. And then because this is a test, we want to do our assert. If you don't do an assert, then there's no way for the test to know whether it passed or not. 4 times 5 is 20, so that would be the correct result. But the assert, this is really where the magic happens when it comes to whether or not the test knows it passed or not. So at this point, we should be ready to run or test or do whatever we want to do with it. If you actually want to run this little web application and see how it works, come over to your Solution Explorer. Right now, our .NET demo pipeline, we can see it's kind of bolded. I know sometimes that's hard to see. This is set up as our startup project. We can also see that under the Start menu here at the top of Visual Studio. If you come over to the Integration API project, right-click, and down near the bottom where it says Set as Startup Project, that will change it to bold and change this to HTTPS. We can run our project. Our test window opens. Our endpoint, we can see it runs and we get the green check. So our test runs automatically. And we get this nice little Swagger page. And if you're not familiar with Swagger, it's a visual API testing tool that .NET bakes into their ASP.NET API project template. Weather forecast is an endpoint that's already set up by default. So you got a little test code in there. It's like an API version of Hello World. But we can see our multiply endpoint from the Integration API project in here. And if you click on this, you can actually run this yourself. So you can click try it out and you can say, okay, well, if it's 5 and it's 5 and I execute, what kind of response do I get? What was the request URL? I can see the parameters being passed and I can see the response I got back is 25 and I know that that's correct. So this is kind of like doing your own bench testing when you want to check, hey, is my API working correctly? Something's wrong on my client side. I can isolate down and say, hey, it's on the API side. But we did see the test run and it ran when we built. It did give me a little warning about finding the HTTPS port. We're okay though. And then again, you could test this out and see what it looks like if you mess with this and say, I am passing 5 and 5. Does my test still run and pass? And we should be able to see that it failed because we expected 20, actual 25. So same deal as with our unit tests. But again, integration tests are really here to see if that glue is working. Now let's come over to our YAML file. So to wrap up, previously we just said run the tests, and we did a .NET test call with no filter or anything. And so if we actually wanted to filter by test category and see like, hey, are my unit tests passing but my integration tests are not passing, we need to make a little change here. So we can categorize our tests and then break this out. So I'm going to update the YAML, and then I'll show you how to annotate and update your tests. So here we're going to change this to say run unit tests only. And so we still say .NET test, we still say no build, but we're going to add filter in here, test category, watch your spelling, no space. We want that to equal unit. And so there's the whole line, .NET test, no build, flag, filter, flag, test unit, or test category equals unit, leaving our verbosity to normal. I'm going to copy this and paste it down here so I can say run integration test only, and test category should be integration. So this way we can separate out our different types of tests in the build and see, are there certain ones running and certain ones not. Now I left this broken so we can see how this works, but we need to actually decorate our tests with the category, that test category decorator, so that it knows which ones are unit tests and which ones are integration tests. So right here where it says test method underneath, we're going to add test category. And then in parentheses, in quotes, this is an integration test. And then same thing for our unit tests. So if we go back over to our Solution Explorer, this was our integration tests, and here are test one calculator tests here. This is going to get test category. Oops, not a curly brace. And it's going to say unit test. So now we should be able to check this in. So I'm going to call it add integration tests. We're going to commit. We're going to push. On our Actions tab, we should see the build happening. Remember, we can come in here, we can click on build, and we can watch as each step takes place. So right now we can see it doing the run unit tests, run integration test. We can see that integration test failed. We can see the run unit test passed. But we could, this is the advantage, right? When you split your tests out, you get this immediate visibility on what tests are failing. If it's a unit test or an integration test, they get to fail separately. And again, the way our pipeline works is it's not going to continue running the operations and like checking the code out and doing other things if one of these fails. So we do get the option to run our unit tests faster before our longer run, usually longer running integration tests. And then we can expand on this further as you build out pipelines, depending on what your application needs, to either trigger tests conditionally, which is pretty common, or run tests in parallel, which can speed up your pipeline process. So hopefully you've learned a bit. And if you want to correct this run integration tests, I know sometimes having a broken test really kind of scratches a strange place for people. You can go fix that call to make sure that they match, or update this to 25 to make sure that they match. And then we can go back over to our Git changes and say updated integration test, commit and push. And then we should be able to see this pass correctly as it walks through each of the steps. So I really hope you have enjoyed this process so far of, we learned about all of these different types of tests, but now you're actually getting into the system, getting into Visual Studio, walking through each one of these, seeing how they work, seeing how the pipeline, keeps our code in check, right? So we can, it does take work. We have to set up these tests. Either we as the developers, you have a testing team, you have a QA team that helps build these, whatever it looks like. It is time consuming to set these tests up. But remember, the goal and ultimately the shining star at the end of the day is confidence that our code is correct and it's quality, while still automating these processes so that they're quick and they don't hinder us in our day-to-day activities. So I will see you in the next video as we continue to work towards building out our pipeline and understanding how these different types of tests integrate in, if you will mind the pun. And I'll see you in the next video. Thank you so much.